Welcome everyone. Today's lecture is on mod, which is continuation of previous two lectures. In previous two lectures, we have seen how to find mean and median of individual data, mean and median of frequency data, discrete data, mean and median of continuous data. So today's lecture is completely based on mod. By the end of this session, you will understand what mod is and why it matters, how to calculate it for individual, discrete, and continuous data sets, real life applications in business, medicine, education, and daily life, step by step problem solving of each type. So, let's begin. So, in today's lecture, we are going to cover five objectives. So, objective, first objective. Here we will define mod clearly with a simple language. At second objective, there are three types of sets: individual, discrete, and continuous. Each needs a different approach. And third objective, real life examples make mod memorable. And fourth objective, by the end, you should be able to solve any mod problem in your exams. And some of last objective, some data sets have more than one mod, so those are called bimodal or multimodal. We will cover those also. So what exactly is the mod? So the mod is the value that appears most frequently in dataset. Unlike mean, which we add everything and divide, and median, which needs sorting. So the mod is the most popular value, the one that shows up the most often. So the word mod actually comes from the French la mode, which means fashionable, the most common trend. So it is represented by Z. In general, we represent it by Z. So look at this quick example. So here we have one example. One data is given here: 3 comma 7 comma 3 comma 9 comma 3 comma 5 comma 7 comma 4. So here we can see that uh, the data value 3 appears 3 times, 4 appears 1 time, 5 appears 1 time, 7 appears 1 time, 9 appears 1 time. So 3 appears most frequently. So mod of this data set is 3. So now there are four different scenarios when we talk about mod. First scenario, when there is no mod. So no mod when no value repeats. So for example, here we can see that when no value repeats, so data set has no mod, so mod does not exist. So here we can see that in this data, this is not repetitive data. So 1 comma 2 comma 3 comma 4 comma 5. So there is no repetition. So no mod. And second type, unimod. So in unimod, we can see here the most common case. This is the most common case. One when one value appears more than any other, more than any other. So here we can see that, for example, here this data set 4 4 appears twice. So 4 appears twice. So 4 is most frequently data value. So mod of this data is 4. And next scenario is bimodal. So two values share the highest frequency. So two values share the highest frequency. Here we can see that, for example, here we have data. So in this data, we can see here 1 comma 2 comma 2 comma 3 comma 3. So 3 appears twice and 2 appears twice. So both are having frequency 2. So mod of this data, there are two mods. And multimodal, so three or more values share the highest frequency. So here we can see that one appears twice, two appears twice, and three appears twice. So this data set has three modes. So now let's dive into the first type, individual data. So individual data means raw data and group data. Each observation is listed separately. This is the simplest case. So the method is straightforward. So method is straightforward. What we do, we arrange the data in ascending order or descending order, and then we count the frequency of each value, and then we identify the value with highest frequency, and that value is the mode. That value is the mode. So here we have one real life example. Here a shoe store recorded the sizes sold in one day. So six size, one pair of shoes, and here 7, 8, and then again 7, comma 9, comma 8, comma 7, comma 10, comma 8, comma 7. So total 11 pair of shoes. Arranging arranging all in ascending order. So 6, comma 7, comma 7, comma 7, comma 8, comma 9, comma 10. So here we can see that 6 appears only one time, and 7 appears 4 times, 8 appears 3 times, 9 appears 1 time, 10 appears 1 time. So 7 appears 4 times, which is the most frequently occurring data value. So mod of this data is 7. So this is a very useful decision. If the shopkeepers know size 7 is the mod, so they will stock more of size 7. They will stock more of size 7 instead of size 10, because size 10 here only one pair of shoes sold. So this is the mod in action. It tells you what's most popular. What's most popular. So now come to the uh, problem based on marks of students. So here the marks of 12 students in a quiz are given. So what we do, this is individual data, this is raw data. So first we arrange in ascending order. So arranging in ascending order, we get 5, 15, 15, 15, 16, 16, 18, 18, 18, 19, 20, 20. So here we can see that next what we do, we can make one table of frequency. So table of frequency, so marks and then frequency. So 15 appears 4 times, 16 appears 2 times, 18 appears 3 times, 19 appears 1 time, 20 appears 2 times. So here we can see that 15 appears 4 times. So the value 15 has the highest frequency 4 times. So therefore mod of this data is 15. So this is unimodal. We can see that uh, only this data has only one mode. So this is the case of unimodal, and this is one real life example in real world meaning. If a teacher sees this, so they know most students scored 15, so which helps them calibrate exam difficulty. So let us apply this to a real life cricket example. So we have five groups of players and exact number of runs each group scored. So here we can see that three players scored exactly 10 runs, and seven players, here we can see here three players scored 10 runs, and 7 players scored 20 runs, and 12 players scored 30 runs, 8 players scored uh, 8 players scored 40 runs, and 5 players scored 50 runs. So here 5, here this is 5 players scored 50 runs. 50 runs. So here we can see that most frequently occurring value is 30. So number of we can see that here the maximum frequency is 12. Sorry, here 12 players uh, scored 30. So 30 runs. So mod equals to 30. So here something very important here, the value 10, 20, 30, 40 and 50 are individual exactly scored. So they are not ranges like 0 to 10 or 11 to 20. So that is what makes this truly discrete data. So this is discrete data. Here we can see that this is discrete data. What is discrete data? So discrete data values presented as a frequency distribution table. So here we can see that here values are presented by frequency distribution table. So a survey. Now come to the next problem based on discrete data. This is discrete data problem. So a survey of 50 families shows the number of children per family. So task is to find mod. So step one, what we do, we look at the frequency column. So we look at the frequency to column. So 4, 9, 18, 12, 15, 2. So the maximum frequency is 18. The maximum frequency is 18. So 18 corresponds to two children. Here we can see that in this method for discrete data, to find mod of discrete data, first we look at frequency table, and then we find in next step we find highest frequency value, and we take corresponding x value, corresponding value. So here corresponding value is two children, so therefore mod is two children. So here we can see that this is the right hand side of table. This right side is uh, this is bar chart. So look at the bar chart on the right. So the tallest bar in red is clearly at two children. So this tells us in this community the most common family size is two children. This information is very useful information, and it is used by government for housing and schooling planning, healthcare providers for services, businesses targeting family products, and see how we can see here powerful. This is power of mod. So powerful one number can be. So now come to the next problem. So what happens when two values share the highest frequency? So bimodal case in discrete data. So here we have one data of blood pressure. This is blood pressure example. Looking at the frequency column. So looking at the frequency column, here we can see that here uh, 12 sorry 15, 15, 22, 22, 22, 15, 22, 22. So both 130 and 140 appear 22 times. Appear 22 times. So both are having same same frequency 20. So mod is 130 and 140. So this data has two mods. This data has two modes. So this is one real life example. So why does this matter? So when a doctor sees bimodal blood pressure, so this is bimodal blood pressure example, blood pressure example data. So it suggests there are two different groups of patients. There are two different groups of patients. Perhaps those with mild hypertension 130, first group mild hypertension 130, and those with moderate hypertension 140. So this could mean different treatment protocols are needed. So what doctor will give different treatment treatment 22 for 22 members, here 130 blood pressure, and 22 members 140 blood pressure. So both groups will be treated with different medicines. So in business, bimodal data might tell you two different customer segments have the same popularity, like small and large sizes being equal popular. So now come to the last data type, mode of group frequency data. Mode of group frequency data, continuous data. So when data is grouped into class interval, so we cannot just look at the frequencies. So we need to use the form. We need to use a formula. So the formula is L plus F1, F1 minus F2, F1 minus F2 divided by 2 F1 minus F1, sorry, 2 F1, 2 into F1 minus F naught minus F2 into H. So what is L? L is the lower boundary of the class of the model class, and F1 is frequency of model class, F naught frequency of pre-model class, F2 F2 is frequency of post-model class, and H is the length of interval, width of interval. So what is model class? Model class is the class interval with highest frequency. So what we do first, we find in given data in problem, we find all values L, F1, F naught, F2 into and H, and then we substitute all values in formula. So let us come to the first problem. First problem based on continuous data. So here, looking at the frequencies, so here we can see that in this data, the frequency table shows the monthly income in thousand of 60 employees. So task is to find mod. So first, what we do, we first step to find model class. So we look at the frequency table. So frequency table, we can see here 20 is the highest frequency. So 20 is the highest frequency, so corresponding class is 30 to 40. So 30 to 40 is model class. So model class, so L, what is L? L is lower boundary of the model class. Here we can see that lower boundary is 30, and F1 is frequency of the model class. So frequency of the model class is 20, and F naught is a frequency of previous class. Frequency of previous class, here we can see that frequency of previous class is 10, and F2 is frequency of next class, post class. Here frequency of post class is 15, and h is the width of class interval. Here we can see that length is 10, length is 10. So 10 to 20, 20 to 30, we can see that length is 10. So what we do, we substitute all values in formula. So by substituting, we get here mod formula is L plus L, and then plus F1 minus F naught divided by 2 F naught minus, sorry, F1 minus F naught minus F2 into H. So by substituting and simplifying, we get 36, 36.67, which means 36,670 rupees. 6076 rupees. So this is mod of given data. So mod of given data is 36,670. So the most, so it means the most typical monthly salary in this company is, so this is data of company 36,670. So HR can use this for salary benchmarking. So let me quickly give you some real life applications. So first application, retail and fashion. So if a shoe company sells sizes 6 to 12, a shoe company sells sizes 6 to 12, and size 8 is the mod. So they order more size 8 shoes. Amazon, Flipkart, Zara all use this mod. So market research, next is market research. So when a company asks which phone brand do you prefer, so the answer with the most votes is the mod. So this drives product strategy. Next, education. Education. So if most students in a class scored 65, that's the mod. So the teacher uses this to set pass marks or review specific topics. Next is healthcare. So in a hospital, if the most common blood type of patients is B plus, so the blood bank stocks more B plus blood. Next is transportation. If peak commute time is 8 to 9 a.m. So mode of travel time data 8 to 9 p.m. 8 to 9 a.m. So mode of travel time, this is mode of travel time data. So transport departments run more buses than. Suppose that here morning session, we know 8 to 9 or 8 to 10, this is peak time, office time. So transport departments run more buses. This is application of mod. Next, last is weather science. The most common temperature in December helps predict a typical winter weather for farmers and event planners. So mod is everywhere. We can see mod is everywhere. We are using in our day-to-day life. So once you know it, you will see it every day. You will see it every day. So let us try uh, one more problem of continuous data. This is healthcare example. Here we can see that here in data weight, here uh, weights in kg of 80 patients at a hospital. One data set is given. So task is to find mod. and interpret the result. So what we do as per the method, first we look at the frequency table. So here frequency column. So here this in this table we have two columns. The second column is this column is frequency column. So here we can see that 27 is highest number. So 27 is highest frequency. So corresponding interval 60 to 7. So 60 to 7 is model class. This interval is model class. So model class, lower boundary of model class is 60. So which is L, and F1, what is F1? As per the definition, F1 is frequency of model class. So frequency of model class is 27, and F0 is frequency before model class. So before model class frequency is 16, and F2 is frequency after model class. After model class we can see that here frequency is 18. And what is H? H is the width of uh, interval. So here we can see that length is 10, 40 to 50, 50 to 60. So here width is 10. So substituting all values in formula. So formula is L, L plus mod formula is L plus F naught, sorry, F1 minus F naught divided by 2 F1 minus F naught minus F2 into H. So substituting all values in formula. So what we get after simplifying? After simplifying we get 65.5 kg. So 65.5 kg is mod of the given data. So it means here we can see that here. So the most typical weight of patients is 65.5 kg. So why this matters? This is because hospital bed weight limits. Hospital, so management, hospital management, doctors can manage the bed weight limits, and medical equipment sizing, and then drug doses calculations based on body weight. So doctors can keep uh, uh, drug doses, medicines based on body weight, based on 65.5 kg body weight. So statistics saves lives. So mod helps doctors make data-driven decision. So a very common exam question is which measure of central tendency should you use? So here's how to decide. So use mean when data is numerical and systematic, no extreme outliers. Example, average exam marks of a class. Use median when data has extreme values. Example, median house prices. And use mod when you want the most popular or the most common value. So data can be non-numerical in mod. Data can be non-numerical. So most sold shoe size, most popular political party, most common eye color. So key differences: mean is affected by outliers. One huge value changes it. Uh, one huge value changes it. Median and mod are not affected by outliers, so they are resistant. So special case, mod works for qualitative data too. So if you survey what is your favorite color, so you cannot take a mean or median of colors. So but you can find the mod. So most frequently chosen color. So these are the some practice problems that you can solve. So You can pause the video and solve and come back after 3 minutes or 4 minutes, and you can match your answer, because answers of all problems are given in next slide. These are the answers here. Answer of first here mod is 22, and answer of second problem here 2 goals per match, and answer of third problem here 42.92 years. So first problem is based on individual data, raw data. Second problem is based on uh, discrete data, and third problem is based on continuous data. So common mistakes uh, and exam tips. So let me quickly cover the most common mistakes students make in exam. So your first mistake, reporting what students are doing here, reporting only one mod when data is bimodal. So data may have more than one mod, and always check all values with the same highest frequency and report all of them. And second mistake, using class midpoint instead of lower boundary. So some of the students and using that common mistakes, using midpoint. So L is the lower boundary point, not midpoint. And third mistake, confusing F naught and F2. F naught is frequency before model class, and F2 is frequency after model class. And fourth common mistake, no mod. So when every value has frequency 1. So when every value has frequency 1, so then no mod. And last common mistake, so not identifying the model class correctly before applying formula. So mostly uh, students are not identifying that during exam students are not identifying model class before applying formula. Thank you for watching. Thank you for paying attention.